Hello and welcome back to Blueprints Academy. I hope you all are doing very well and I welcome you all to our today's episode where we would be discussing about the deployment. Before we start, a little introduction of myself so you know who is your speaker for today. My name is Aditya and I have over 7 years of experience working in data engineering domain. I am currently working for one of the leading marketing company in Europe and I am currently based in Germany. So just to give you a little bit of recap, what we are doing as part of this series. So we are building this simple ETL pipeline where we are pulling the weather API data and pushing it to S3. And finally, we would be having an Athena table to query this data. So if you see this architecture, we have an event bridge rule, which is gonna trigger our Lambda function every 5 minutes. So this pipeline is near real time. And then the first Lambda will be responsible to pull weather API data from open source weather API and push this event to another Lambda as part of internal Lambda invocation. And the second Lambda gonna be doing some kind of transformation and then pushing it finally to S3 in the form of Parquet. And then on top of S3, we have Athena running where we can query or analyze the data. In the last videos, actually, we discussed this architecture, we discussed the local development environment setup. We also did the exercise where we built this Lambda code where we are actually calling the APIs and pushing this data to S3. If you didn't get a chance to watch my previous videos in this series, I highly recommend you to watch those videos so you know where we are in this series and you are well in line with the current process, what we're going to discuss later on. So what we will cover today. So first thing that we would be discussing is the deployment flow. So as of now, we have everything on our local. Now is the time that we need to deploy all this local stuff to AWS. So we would be discussing the deployment flow. Second thing, we would be packaging and deploying the Lambda functions to AWS. And here we would be using Docker. More about this later. And third thing, we would be creating our required infrastructure like event bridge rule and Athena tables via Terraform. So let's get started. Let's understand how we're gonna be deploying our code and our infrastructure to AWS. So if you see, currently we have this piece. We have our Lambda code. We actually have two Lambda. One is ingestion job, another one is normalization job. And this ingestion job, what it is doing, it's first calling the weather API and then it's invoking next Lambda, which is in our case normalization job, which is actually doing the transformation on this API call event and then pushing it to Parquet, pushing it as Parquet to S3. And also this first Lambda is pushing these raw events as JSON on S3. So all in all, we have ingestion job and normalization job, which is nothing but a Lambda code, which we tested on local. So we ran the job from local and we tested it and it's running fine. It was in the last video, just in case if you are wondering. Now, what we need to do. So on AWS, we typically need these three resources. So as per our architecture, we need an event bridge rule. We need an Athena table. We also need a Lambda function. Now, if you see event bridge rule, we can create these resources on AWS in many different ways, right? So some of the ways I mentioned here. So you can create these resources on AWS either via AWS console, which is the easiest way, or you can use CloudFormation, or you can use Terraform, which is in our case, we're gonna be using Terraform, or you can use any other infrastructure as a code framework like AWS CDK or something like that. So if you want to create these resources, it's like straightforward to create via these frameworks, but there is a catch. For Lambda functions, you actually need two things to deploy. The first thing is Lambda code, which is written in Python. And second thing is the actual Lambda resource that we can of course again create via any of these ways. So I hope this is clear. So we need to somehow push this code as well as the Lambda resource to AWS. And to do that, we need some kind of a script, right? Which can push our stuff from local to AWS, right? Now this script can be divided into two forms actually. So one is that we gonna write Terraform code which will create these resources. So I can write literally Terraform code to create event bridge, to create Athena, to create Lambda function. But for lambda function, we also need something which can package and push this lambda code, which is nothing but the Python logic, right? So to do that, we again got two ways, right? First way is you can literally write your Python code in the Terraform resource creation or CloudFormation resource creation. But this is not ideal in our case because our code is heavy. We are using external libraries. So it's not advisable to write this Python code in Terraform template itself. So this solution will not work in our case, but this exists. The second way would be to somehow package this code in wheel or egg file and then push it or connect it to the lambda function. This will also not work in our case. Why? Because we are using couple of external libraries like pandas, numpy, pyro. So this is also not an ideal way. Now, if you are using any external library with lambda, you got two options. One option is to use lambda layers, which is more common, more famous, and many people might already know. So for each library, so in our case pandas, numpy, pyro, we would create a lambda layer and attach that layer to the lambda function. But here is also a limitation. So lambda allows only 250 MBs of everything combined, like lambda layers, and that too in uncompressed form. So let's say you have a lambda code and then you attach two layers to that, let's say pandas and numpy, and now this whole code or whole package should not exceed 250 MBs uncompressed. And another way is using Docker image. So with Docker, you get more flexibility to do what you want to do. And in our case, we need more flexibility because we are using couple of libraries like pyro, which are a bit heavy and of course gonna be more than 250 MB. So in our case, Docker image would be the best solution to deal with lambda. Now, if I summarize, so in our case, we would be writing Terraform template to create. Okay, let me zoom in, zoom out. So we're gonna be writing Terraform code to create all these resources, and along with that, for lambda functions or lambda code, we would be using Docker image and packaging this whole logic of lambda in a Docker image, pushing the Docker image to ECR, and then using that ECR to create lambda function. I hope this is all clear, and now we gonna be dealing into the actual code of Terraform and actual code of packaging stuff and pushing to AWS. I am here in my IDE and this is our folder structure, or I would say project structure. You might already be familiar with this. If not, then please watch my previous videos. We discussed why we have this kind of a structure here. Anyways, so now we need to see. So just to give you a recap, this is where our code resides. So under Lambda, we have our ingestion job. If you see, it reads from this API and then it is actually pushing to S3 and it's also invoking the Lambda. This is commented out at the moment because we don't have Lambda at the moment provisioned, right? And then we have another job which is doing some transformation and then pushing it to S3 again as part of as a Parquet. Where it is here as a Parquet partitioned by R. Now this is the logging where we have a little bit code for logging framework. We have a utility function where we are doing very little transformation. So this is all and all our code. Now what we just discussed as part of our deployment flow is we need to create a Docker image which can encapsulate this data or package this Lambda code and then push it to ECR, which is Elastic Container Repository. Now, please ignore these Terraform red files at the moment. And if you see our infra folder, I have a Lambda folder inside and I have two files. One for ingestion, so one for first Lambda code, and second one is for the second Lambda code. And now if I go here, so you probably are not interested into this piece, so I am using this code from UV website, how they suggest me to use UV for packaging Lambda. So the main thing that you would like to know is this copy piece. So you see we are copying everything under this ETL folder to our containers ETL folder, and then we say this is our entry point or the command that it should be running when we spin up this container or when we run our Lambda code from Lambda function from AWS. Now, these files are literally same. The only difference is this entry point, or I should say command, because Lambda does not support entry point, just in case, like any other container services. So we have two Docker file, each for each Lambda, and they are doing literally nothing, but there is just this command is different. I know this is very redundant and you might be thinking why I have this copy paste. So this is gone. I'm just trying to make this very simple. That's why we have a copy paste thing. But in general, what you would like to do is to have all this piece as a separate Docker image, and then you would deal with something which is called multi-stage Docker implementation. So you're gonna have common stuff running in a separate Docker file, and then you would use that Docker file as a base image for this Docker file, and then you do your stuff on top of that. So which is called multi-stage Dockerization or multi-stage Docker build. But Docker is not part of this series, so it's okay to have copy paste at the moment. Now we have the Docker file. Now, what do we need? We need a script which can build this Docker file and push it to ECR, right? So this is the script. Now, if I go through very quickly, actually the script explains everything itself because I have the comments written. So here we create the repository if it does not exist. Once we create the repository, we are logging into the ECR repository. Then we build the image one after another, and then we tag it with the latest, and then we push it to the ECR. It's simple. So the moment you run this script, what it's gonna do, it's gonna create the repository if it does not exist. We're gonna log in there, we're gonna build the image, we will tag it and then push it to the ECR. And how you would run it is like this. uv run sh package.sh, and you see login succeeded. It's building the image, and because for me it's already exists, so it's pushing the image to ECR, and you can see here it is, normalization lambda push to the ECR. So this script can be used to push the images, build and push the images to ECR. Now we have the image on ECR. Now what we need is to create this lambda using this image, right? So for that we will be using Terraform. And if people do not know how Terraform works, so in Terraform you have mainly three files. One is main.tf, second one is output.tf, another one is variable.tf. Main.tf is the file where you would be having your actual resource creation, like IAM role or whatever kind of resource you want to create, that should reside in main.tf. Output.tf would return an output that you want should be displayed on the console or on the CI/CD if you run this via CI/CD after creation of the resources. Variable is something that you would like to pass on runtime when you run this Terraform script. Now, there are also a couple of files like provider.tf, backend.tf, but those are not part of this scope, and you can keep them not here in this repository at the moment, and this will work as smooth as you can think. But in production, you really want to do this backend.tf, provider.tf, but that's more of could be a part of a Terraform course, not the course that we are dealing with, right? Now let's quickly go through this main.tf, what we are doing. So we say we need to use Terraform from HashiCorp. Fine, we have AWS. This is the reason where I am or where I have my resources. Now we are creating the Lambda execution role. We are attaching the policy where it's basic execution policy. Then we create the Lambda function. This is interesting, right? So we are creating two Lambda functions. If you see ingestion job, normalization job, and if you see the package type, we have image. And when you say the package type as image, sorry, you probably want to pass the path of the image. And in our case, if you see, this is the path from the ECR where we just push this image. It's literally this path. And timeout 60. It's literally same, just the change in the name of the image. Then we also have a event bridge rule, which will trigger our Lambda function every 5 minutes. Then, so when you create a event bridge rule, you have to create this resource and then you have to also create a target. So every 5 minutes, trigger this Lambda. And if you see, this is the Lambda target and this is the ARN of the Lambda that we want to trigger. Now we also need to, of course, give some kind of access or provide a couple of access to this event bridge rule so it can invoke the Lambda function, and those access are represented here. Then we are creating a Athena table, which is quite simple: location, input path, and then couple of properties that you might already know. Then of course the columns that we want in the table, and then the partition key. So that is what we are doing. So all in all, we are creating event bridge rule. We create two lambdas and we create Athena table, our database as well. And once we run this script, it should give us the ARN of both the functions once created, and the variable is the runtime account ID that we want to pass. So now let's run this script. To do that, I would go into infra folder. So Terraform can identify Terraform, and then I would say Terraform plan. Oops. Terraform plan. So it should generate the plan. It's asking me for the runtime account ID because it's a variable, and I have it in the environment folder, and this is the ID. So let me just pass it and let's see what plan it generates. So this is actually a cool thing about Terraform as opposed to CloudFormation, that before even applying these changes, you can see what it's gonna do for us. So if you see, everything is green and plus, which means it's gonna create everything. So I don't have anything in my AWS environment yet. So this is what it's suggesting, that when I run this Terraform apply, it will create everything, which is plus create, and then if you see, everything is mentioned here. So this is very cool part about Terraform. Now we know the plan, everything gonna be created, like 9 to add, 0 to change, and 0 to destroy. This is the main thing that you would like to focus on. Now let's do Terraform apply. Let's again pass this value, and yes, we want to create the resources. So now it's creating the resources, right? It will take couple of minutes to create the resources, but should be fast enough because we don't have much to create, to be honest. And you can of course see the logs and everything. And just because it's creating and I have a time to explain, I can quickly explain what these log file state files are doing. So whenever you create resources, from local, uh, Terraform has to keep a state of the object, right? For example, you are doing some updates to the same object or same resource, then Terraform needs to know, okay, this needs to be an update onto a resource, not the creation of a new resource. So for that, it does this whole temporary file creation. But in production, you would keep this shared state file on some shared location, probably S3, and for that you will have to set up couple of things in the Terraform directory, like backend.tf, provider.tf. Okay, so we have our ingestion normalization function created, and you can see the ARN, which are actually printed because we have output file in our code. So now we have our infra setup. We also deployed our Lambda using ECR. Now let's see everything on AWS, how it looks like. I am in my AWS account, and let's first see our images. So if you see, this is the ECR repository, and you can see the repository name. And then if I go inside, you can see the images. I was testing, so we have so many, but we are interested into this latest one, which we pulled just some time back. And similarly, we have another repository for another Lambda, and then we have its corresponding image. So these are the image. Now let's go to Lambda and see if we have both the Lambdas created using these two images. So you see, we have both Lambdas created: ingestion job, normalization job, and package type is image, and it was last modified 4 minutes ago. We are also interested to see the event bridge rule if it's created or not. So let's see our rule, and we do have a rule. And let's see the target quickly. So fixed rate at every 5 minutes, and target is our lambda function, which is ingestion job. Perfect. We can also see our Athena table. And if I see, this is the analytics DB, and this is the table which has everything which we have created, and it is also partitioned based on R. So I think everything is set up, and we are good to do the testing, which is not part of this episode. You'll have to wait for the next one for that. This was all for today's video, and in the next episode, what can you expect? So, as I said, we would be doing all full end-to-end testing of whatever we deployed in the next video. So in the next video, we would be doing end-to-end testing of our ETL pipeline on AWS, which we just deployed. We would be analyzing the data on Athena. We will also understand how you can troubleshoot when there is failure in the job, or when there is a failure on any stage in the job, and where you can see the logs and how you can fix them. And when it comes to fixing the bug, you probably also want to redeploy the changes, right? So we would be also discussing how you can redeploy these changes and what things to keep in mind when doing the redeployment. And finally, we would be closing this series with the final thoughts and best practices that you should do when building the data pipeline. So I will be seeing you again in the next video. Until then, thank you for watching today's video and have a good day. Thank you for watching.